In this video, we're going to start section 6.1 on similar triangles and special right triangles. Our goals are to recognize when we have similar triangles and set of proportions to find the lengths, missing lengths in similar triangles. And then also to determine the side lengths of special right triangles, so 45, 45, 90 triangles and 30, 60, 90 right triangles. Okay, all right, so what are similar triangles? Well, two triangles are similar if and only if their corresponding angles have equal measure. Okay, so what do we mean by that? So let's suppose we have one triangle. Suppose we have one triangle that looks like this. Okay, and then there's going to be another triangle whose angles all match the angles in this first triangle. Okay, so I'm going to label this first angle with 1 tick mark, the second angle with 2 tick marks, the third angle with 3 tick marks, 1, 2, 3. So I'm going to draw another triangle that's got those same angles, but maybe it'll be a bit larger. So I'm kind of matching the shape. Okay, and with this triangle, so this angle matches that first angle of the first one with 1 tick mark. This one at the top will have 2 tick marks, that matches that second angle at the top. And then this one in the bottom right corner, I'll put 3 tick marks. Okay, and let's suppose that this length is 1, this length is 2, and in the big triangle, this length is 5. And this length over here, let's say, is unknown, and I'm going to call it x. Okay, so one key property of similar triangles is that their sides are proportional. Their sides are proportional. Okay, so I can set up a proportion to solve for this missing side length x. Okay, so what would that look like? There's a few ways I can set it up. But one way is, in the first triangle, I could write 2 over 1. So I'm setting up a ratio for its sides. And that's going to equal a ratio of the corresponding sides in triangle number 2. Okay, so the 2, whoops, let me go to highlight mode. This 2, this side, that corresponds to the x. So that needs to be going on the numerator in my proportion. So notice that the 2 and the x are both in the numerator of this proportion. Okay, and I've put 1 in the denominator. I've put 1 in the denominator of the proportion. So on the other side of the proportion, I got to find what's the side that corresponds with a 1. And that is the 5. Okay, so 5 should go on the denominator over here. So I got this proportion. Got this proportion. 2 over 1 equals x over 5. And I can use this to solve for x. So if I multiply both sides by 5, well, first off, let me just simplify. This is 2 equals x over 5. And now if I multiply both sides by 5, we'll get that x equals 10. X equals 10, and that is that missing side length. Okay. All right, so one thing to notice about this is, if this is 10, one thing we might notice is, wait, everything in this bigger triangle, all of these side lengths are just getting multiplied by 5. Notice the 1 got multiplied by 5, and the 2 got multiplied by 5. So that's going to be the case in similar triangles. All of the lengths of the bigger triangle will be the lengths of the smaller triangle, but just all multiplied by that some constant. It doesn't always have to be 5, but it'll be some constant. All right, so let's do an example. Let's do a word problem example. So this says that a 5-foot woman is standing 12 feet away from a 21-foot lamppost. And then how long is her shadow? How long is her shadow? Okay. All right, so I first want to give you a couple minutes to try this. So pause the video for about 3 minutes and see if you can draw a picture and get this thing started. 4, 3, 2, 1. Pause the video. Pause it for about 3 minutes to try this. All right, so hopefully you did that. Hopefully you paused it and tried it for about 3 minutes. Let's talk about it. Okay, so what should I have in my picture? Well, it says there's this lamppost. So I will draw this tall lamppost. Okay, so light is emanating from this lamppost. Okay, and this is on the ground. Okay, and then some distance away from the lamppost, we have this woman. We have this woman. All right. And we know the height of the woman. We know the height of the woman is 5 feet. We know the height of the lamppost. We know that's 21 feet. And we also know the distance between the lamppost and the woman. We know that's given to be 12. The woman is 12 feet away from the lamppost. Okay, and then it talks about how long her shadow is. So it's going to be helpful to draw one extra line in the picture. So to see how long her shadow is, well, that's determined by when this light kind of grazes the tip of her head. Everything kind of before this point on the ground is going to be where her shadow is. So this whole thing over here, well, that is where her shadow is. Okay, so we don't know how long that is, so maybe I'll assign a variable to it like x. All right. Okay, so one thing to observe in this picture is we have some similar triangles. So I have this big triangle that the lamppost makes with the ground and this light beam. Okay, so I'm going to draw that big triangle. And in fact, that's a right triangle. The lamppost makes a right angle with the ground. Okay, and then there's this small triangle made by the woman's height and her shadow, and this side over here. I'm going to draw that side small triangle. So we have these triangles. We have these two triangles, and they both have that right angle. They both have that right angle. Okay, and they both share one angle, like both the big one and the small one. They both have this small angle over here. So I'll mark that with one tick mark. And if two of the angles in the triangle match up, the third one has to match up because they all have to add up to 180. So because of that, this third angle at the top, well, they have to match up. I'll put two tick marks at both of them. Okay, so let's label the lengths that I know in the picture. So we're saying the length of the shadow, that's the base of the small triangle, is x. The height of that one I know is the height of the woman, that's 5. And in the big triangle, that height is 21 because that's the height of the lamppost, and then the base is 12 plus x. All right, awesome. So because we know at this point that all three angles in the triangles, they have corresponding measure, we have some similar triangles. We got some similar triangles. Okay, so in general, if I can find two pairs of angles that are equal, well, the third pair has to be the same, and then they're going to be similar. So now I can set up a proportion. So maybe in the small triangle, maybe I'll write, let me put this in black, maybe I'll do x over 5 in the small triangle, and now I got to do corresponding sides in the big one. So the x corresponds to 12 plus x in the big one, and the 5 corresponds to 21 in the big triangle. Okay, so now I got fraction equals a fraction. I can cross multiply to get 21x equals, if I multiply 5 by that 12 plus x, I got to distribute 5, and I get 60 plus 5x. Okay, so subtracting 5x, I get 16x equals 60. And dividing 16, I get x equals 60 over 16. And I can simplify, I can divide the top and the bottom by 4 to get 15 over 4. And okay, so that's the length. I just need units, and the units here are feet. Okay, so that is the length of the person's shadow.